All right, here are the notes from yesterday, right? We talked through the long way, and then we talked through the shortcut. When can you use the shortcut? When A equals 1, right? So what are we going to talk about today? When A does not equal 1. Okay, when A does not equal 1. Now, do you remember the good news from yesterday? What's the good news from yesterday? Yeah, I already taught you how to do this yesterday, didn't I? It's the quote-unquote long way from yesterday.
Oh, yeah.
And when I taught you the long way, you said it was pretty good, right? So I'm just going to show you again. I'm going to show you 4 examples again. And I know some of you like to know like what kind of room you're going to need for your examples. So I'm going to just divide this space in half and divide this space in half. And we'll use we'll have 4 examples. Okay? Now, these two will have 4 lines, like 4 rows of lines for the problem. These two on the bottom will have 5. Okay? So, top example, first example. 2x squared plus 17x plus 21. Well, knowing what you know from yesterday, what are we going to have to do first? A, C, and B. So what in this problem, what is A? 2. In this problem, what is B? 17. And in this problem, what is C? 21. Is everybody okay with that? So in this problem, what is A, C? 42. And what is B? 17. So what do we have to think about here? What 2 numbers multiply to be 42? Very good, and add to 17. So this might take a little bit of thought, and for some of you, respectfully, for some of you it might take a little bit of calculator work, right? You might need your calculator out, and hopefully you won't have to say 42 divided by 2, right? Because first of all, we just multiplied 2 down to 21 to get 42, right? So you know that's 2 and 21. Do 2 and 21 add to 17? No? Okay. 3. Remember when we talked about how to tell if things are divisible by 3 the other day?
Yeah.
How do you tell? What's 4 plus 2?
5.
6. Is 6 divisible by 3? Then so is 42. So it's 42 divided by 3. $14.
Yeah.
Does 3 and 14 make 17?
Yes.
Oh, good, right? And if it didn't, we would have to check the next number and the next number until we found 2 multiples that add to 17, right? Okay, but I know it's 3 and 14, so I'm going to write 2x squared plus 3x plus 14x plus 21. Now, where did I get 3 and 14? Those were the numbers that multiply to be 42 and add to be 17. And I took my middle term and I split it into 2 parts. Remember that?
Yeah.
Okay. Now how many terms do I have? 4. And how do I factor something with 4 terms? Or how do I try to factor something with 4 terms? With grouping, right? Absolutely. So what's common in the first 2 terms? It's just x, right? Because they're not both divisible by 2. That was a good thought, but it's just x. So if I factor out an x, what do I have left? 2x plus 3. Very good. What's common in the last 2 terms? 7. If you couldn't tell that right away, could you realize we need another parenthesis that started with a 2x and think, what do I have to divide 14 by to make it be a 2? Does that make sense? We talked a little bit about that the other day, but now it's really coming into play, right? So if I divide it by 7, what do I end up with? 2x plus 3. So what do these 2 terms have in common? 2x plus 3, and what's left? X plus 7. And we're done. Okay? Now, there's usually a question at this point And nobody asked it out loud, but I'm almost willing to bet, if I was a betting woman, that some of you thought it. Okay? Because you guys said 14 and 3, and some people said 3 and 14, so I wrote 3 and 14. What would have happened if I would have written 14 and 3? Can I show you? Can I show you? Okay. If I would have written 14 and 3, look what would have happened. I wrote 14 and 3 in this example, right? Look at the answer I got, and look at the answer I got. It's the same, isn't it? Okay? So does it matter what order I write those two things in? No. What matters is I keep the sign with the right number, right? It didn't really matter so much this time because they were both positive, right? But if I write 3x and 14x, or if I write 14x and 3x, I'm still going to get the same two factors that I got. Everybody okay with that? Okay? All right. Next example. 5x squared minus x minus 18. 5x squared minus x minus 18. So first, okay, so A is 5 and, okay, oh, time out. Right? A is just 5, right? Okay, and what's C? Negative 18. So what is AC?
5 times.
Which is what you all have permission to use your calculators on this. All of you. It's not 400, I'll tell you that.
80. Negative 74. 100. Negative 190?
No.
Negative 185?
No.
Negative 180?
It's negative 90. Thank you.
I added 100. Why did I add that? I was there. I just.
And what's B? Negative 1. So what two numbers multiply to equal negative 90 and add to be negative 1? 9 and 10. What kind of 9 and what kind of 10? Because I need it to add to be negative 1, it'll have to be negative 10 and positive 9, right? Okay, so rewrite your problem, 5x squared, but this time using negative 10x plus 9x minus 18. Remember, I split that middle term into two parts. Okay, and now that there's 4 terms, I'm going to factor by grouping, right? So what's common in the first 2 terms? Close. 5x, right? If I factor out of 5x, what's left? X minus 2. Very good. What's common in the last 2? 9. If I factor out of 9, what's left? X minus 2. What's common in these 2 terms?
X minus 2.
X minus 2. If I factor out an x minus 2, what's left? 5x plus 9. Done. Okay, so far? Third example. 3x cubed minus 5x squared plus 2x. Why are you oohing like that? It's weird, okay? But I still talk to you guys even though some of you are weird. Right? So we still need to do the problem, right? Okay? Why are you saying it's weird? What makes it different than the ones we've done before?
It has a cube.
Has a cube, so this is when we freak out?
No paper.
No, this is when we notice that they all have an x. And if they all have an x, isn't that a greatest common factor? That I can factor out first? If I factor that out first, what am I left with? 3x squared minus 5x plus 2. Now if I just ignore this x for a second, I'm not ignoring it, I'm just ignoring it for a second. If I ignore it for a second, is that any different than either of the problems that I did before? No, not at all. Okay? So by taking out the greatest common factor first, I've actually made it easier on myself, haven't I? Okay? So now I still have to drag...
Kingston,
Yes?
is Connor Mackey?
Yes, I do.
Come to the office, please.
Yes, I will. I still have to drag this x along because I can't just forget it because it was part of the original problem, right? Okay, but now I need to do AC based on just the thing in the parenthesis and B based on just on the thing in the parenthesis, right? So what's AC for this problem? 6. And what's B? Negative 5. So what two numbers multiply to be 6 and add to be negative 5?
Negative 3 times negative 2.
Do you want this?
Yes.
Can I see a picture of it?
Negative 3 times negative 2 is positive 6 and adds 3 negative 5.
So what are we going with?
Negative 3 times
Negative
2.
3 and negative 2? So 3x squared minus 3x minus 2x plus 2. Why were we fighting about that? They didn't believe you?
You got no faith.
No faith.
Reach.
Bruh.
Oh, real.
All right, now that there's 4 terms, I can factor by grouping, right? Still dragging this x along. What's common in the first 2 terms? 3x. If I factor out a 3x, what do I have left? X minus what? What's 3x divided by 3x? 1, right? Okay. What's common in the last 2 terms? Oh, Sue, I'm super glad you said that, right? Because I don't want you to notice that they're only divisible by 2, because, well, they are. If I divide out a 2, will that give me the parenthesis I need? No, it won't, right? So we know we have to factor out a negative 2, because if I divide each of these 2 terms by negative 2, what do I have left? X minus 1, which is what I need, right? Okay? So now, again, dragging this x along still. What's common in these 2 terms right here?
X minus 1.
X minus 1. And what's left if I divide out an x minus 1?
3x minus 2.
3x minus 2. Done. You okay?
So that's a right answer.
That is the right answer.
That's free.
Almost like they doubted my 3 and my 2.
One more example. You ready? Okay. 4x squared plus 2x minus 12. Nobody oohed this time, but isn't this weird also?
Yeah. Nah. That's pretty big.
It kind of is.
On the basis.
Yeah, because there's a plus and a minus.
We've been through that. We've been through that. That was yesterday. You weren't here.
Well,
Yeah.
Well, tell me why it's
No,
weird.
no, no,
Okay,
listen,
so-
listen. Aren't they all divisible by 2?
That's what I was thinking.
So shouldn't I factor the 2 out first? Do I have to? Now, remember what our directions are always going to be. Factor completely, right? And so if I got to the end and got 2 factors down here, and one of them had like a factor of 2 inside, I would have to pull it out then. I'd have to factor it out then. Well, I could do that, but if I multiply 4 times 12, that's going to, or negative 12, that's going to be negative 48, right? But if I factor out a 2 to begin with, that's going to be a 2 and that's going to be a 6, and I'm having to deal with factors of 12 then instead of factors of 48. So do you see why I wanted to pull the GCF out first? It'll make the numbers that I have to deal with smaller, right? So factor out a 2, and what do you have left? 2x squared plus x minus 6. Why didn't we factor out a 4 instead of a 2? Exactly. The middle term is not divisible by 4, is it? Okay. Now, what do I do from here? What do I do with this 2? Keep it, but ignore it, right? What's AC? Negative 12. And what's B? 1. So what 2 numbers multiply to be negative 12 and add to be 1? 4 and 3. What kind of 4 and 3? Positive 4, negative 3, right? Does that make sense? Okay. Drag the 2 along. Rewrite my problem, splitting my middle term into 2 parts, positive 4x and negative 3x. That's what you said, right? Okay. Drag my 2 along. 4 terms, so trifactor my grouping, right? What's common in the first 2 terms? 2x. What's left? X. Oh, what is that? X plus 2. What's common in the last 2 terms? Negative 3. Good catch, right? Good catch. Negative 3. And what's left? X plus 2. Very good. Still dragging the 2 along. What's common in these 2 terms? Very good. X plus 2. And what's left? 2x minus 3. Done. Questions? You good? Feeling confident in this? Some of you yes, and some of you not so much. Well, we have some time to work on this, right? Well, you know what? You can ask questions to me if you need help, right? Can you work with your group? Can your group help you answer questions? What can your group not do? Give you answers, right? You understand the difference between helping you through a problem and giving you answers, yes? Good. Any questions about this?
What you did.
You ready? All right.